Implied domain basically means what does the domain have to be. Sometimes it might be a real world problem where negative values don't exist, or sometimes it could be something where you can't have any decimal or fraction values, where everything needs to be whole number, such as maybe people getting on a bus. You can't have 2.5 people getting on the bus. It doesn't matter if they're short or tall, they still count as one person. So, if you take a look over, here we have area of a circle is equal to pi r squared. Since we are talking about real life situation, your radius has to be greater than or equal to 0. So because that's the case, we can't have a negative radius. So what we'd end up doing is we would say our domain has to be greater than or equal to 0, in which case we could just say either r greater than or equal to 0, or we could say with a bracket 0 to infinity. So sometimes, you might decide if it's what's realistic and what's not. The next one we have f of x equals 2 divided by x minus 3. We know that the denominator cannot equal 0, so that's what we're going to end up using. So if I set the denominator not equal to 0, I get x minus 3 can't equal 0. When we work it out, add 3 to both sides, and we get x cannot equal 3. So you could say, with interval notation, which is what we'd be using, we would say our domain, and it's good to write when you're working with domain and range, to label, especially with interval notation, to label a D, a big D for domain, and then that way you know it's especially if you have parentheses, it's not an ordered pair, but is actually a set value. So since x cannot equal 3, I would do a parentheses, negative infinity to 3, close the parentheses, but it's a parentheses because we can't include 3, do a U for the union, another open parentheses, and then we go 3 to infinity. So there is our domain for the rational function. For the next one, we have f of x equals square root of 9 minus x squared. So basically what we know is we can't take the square root of a negative number. So 9 minus x squared has to be greater than or equal to 0. This is a difference of squares, so I end up with 3 minus x times 3 plus x greater than or equal to 0. Set each one equal to 0. So I got 3 minus x greater than or equal to 0, and over here I got 3 plus x greater than or equal to 0. Over here, if I add x to both sides, probably the best way to go. That's a plus, by the way. I get 3 greater than or equal to x, which if I flip the order around, I get x is less than or equal to 3. On the right side, I have moved the 3 over, and we get x greater than or equal to negative 3. So what I'm going to do now is I'm going to draw a quick little number line. This will come in handy. And label what we call our critical points. So the 3 and negative 3 are our critical points. So negative 3 and 3. So what I'm going to do is I'm going to create what's called a test point. Pick a number to the left of negative 3, say negative 4. If you plug negative 4 in to the equation, so I get 9 minus negative 4 squared, which will end up being 9 minus 16, I get negative 7. And we can't take the square root of negative 7. So this part over here does not exist. So now I'm going to pick a point in the middle. Say 0. 0 is a nice easy one. When I plug 0 in for x, I get the square root of 9 minus 0 squared. And I get square root of 9, and we can find the square root of 9. So this area right here is okay. For my next critical point, I'm going to pick something bigger than 3. I'm going to say 10, just because it makes the math a lot easier. I'm going to plug 10 in for x, and I'll get square root of 9 minus 10 squared. This ends up being square root of 9 minus 100, and that's going to come out square root of negative 91, but we can't take the square root of a negative number. So this right here does not exist. So for our implied domain, it would be all the x's. Probably skip through some of this. My implied domain would be everything between negative 3 and positive 3. And since we have the equal to, that's why we have the brackets.